Okay. Okay, so biofuels sound great in theory, right? We're running out of fossil fuels, but we can make comparable fuels from plants that are growing all around us. But even though it sounds like a great idea, there's still lots of things we don't really understand about plants that limit the efficiency of this process. So plants are surrounded by a tough outer layer of cells, which is called the cell wall. And it's kind of like the exoskeleton of insects. So the exoskeleton makes like cockroaches really hard to kill. And then it's the same thing for plants. It makes them strong and it protects them from environmental hazards or whatever they may face out in nature. So how do we efficiently destroy something that has evolved over millions of years to not be destroyed? That's the challenge we're facing. So we know that the cell wall is made up of long sugars that are mostly linear, and they have lots of side branches and modifications. But we don't know how they interact at the molecular level to give the cell wall strength. So to clarify this, we have to understand how the thing is actually made. And the molecules which build these structures are called enzymes, and there are literally thousands that work together just to put the cell wall together. So you're probably wondering, or have been wondering, what this all has to do with Legos. So if you'll just follow me through this maybe complicated analogy, it'll hopefully make sense. So we've all probably played with Legos at one point in our lives, or if you're like my boss, like we were talking about, you still do. So, so just let's say that this is the cell wall. This is the structure we have. We know this is what it looks like, but we don't know how it's all put together. So that's what we're trying to find out. So just imagine trying to put this together yourself, but without any instructions or have any idea how to do it. That's kind of how we're looking at this. So we know this is a structure, but we don't know the players behind it. So this is where the enzymes would come in. So say one enzyme can only add this block, but it can only add it if this other one is adjacent to it, or if this other one has been added like 10 steps behind it. You know, we don't know what the specificity of these things are. So that's what we're trying to figure out. What conditions are these enzymes working under? What specificities do they have? And how can we make this overall structure, but with enough modifications for plants to still grow and thrive, but be more amenable to becoming a renewable fuel source? Okay, thank you.